In this video, we will begin investigating the differentiation formulas. Now, the key idea here is that this process of finding the derivative using the definition of the derivative. We've seen even for the very simplest of functions that we encounter is time-consuming and we might say a bit tedious. But fortunately for us, there are actually several rules of differentiation. We might think of these as being the shortcut formulas that we can use and find derivatives without using this definition directly. The first two such rules would be the constant function rule. What the constant function rule tells us is that the derivative of a constant is always equal to 0. Now this is something that we can maybe very easily see from a geometric perspective. If we have the function f of x equals k, its graph would be represented by y equals k, which is a horizontal line. And if you pick your favorite point on this line and draw the tangent line at that point, the tangent line is going to be the line itself, which has slope 0. So the derivative is going to be 0. So the derivative of a constant is 0. Additionally, we have the power rule. That tells us that if we have x to the n, where n is any real number, its derivative is going to be nx to the n minus 1. How I remember this is when I'm looking at x to the n, and I'm thinking about differentiating it, the power n comes down front, and the new power is 1 less. So the n comes down front, the power of x is 1 less than it previously was. Now, two more basic rules are the constant multiple rule and the sum rule. The constant multiple rule very simply tells us if we have the derivative of a constant times a function, you can pull the constant out in front of the derivative. The sum rule tells us that if we have the derivative of a function plus a function, i.e. the derivative of a sum, we can break that up in terms of the derivative of the first plus the derivative of the second. So the derivative of a sum is the sum of their derivatives. And the idea here is just to break it down into as many simple, easy to differentiate functions as possible. So let's look at a few basic examples. Let's use the rules of differentiation to differentiate the function 2 over x squared. Now, at first glance, you might not think that we can apply the rules of differentiation because this is a quotient. We're dividing two functions, and we haven't seen how to do that. But recall, having this exponent of 2 in the bottom can be rewritten as an exponent of minus 2 in the top. So this is very well suited for us to use the power rule on. And the power rule tells us that the derivative of x to the n is nx to the n minus 1. But before using that power rule, we are first going to use the constant rule. So if we have a constant, which in this case is the number 2 times x to the minus 2, we can pull that constant in front of the derivative and write this as 2 times the derivative of x to the minus 2. And this notation, just to make sure we're all on the same page, when we see the d dx, that means differentiate this expression with respect to x. And the power rule tells us when we differentiate that, the minus 2 comes down front, and the new power of x is 1 less than it previously was. 2 times minus 2 is minus 4, and then that's x to the minus 3. And a slightly more simplified way of writing that will be minus 4 over x cubed. And I'm going through each and every step with these first few examples, but let me just note as you go through and practice more of these problems on your own, and you become comfortable with using these rules, you will become very quick and very efficient differentiating functions such as the one given here. So next, let's differentiate the function x to the 4th plus 5x squared. And once again, I'm going to go through all of our rules of differentiation, but after a few examples, you would certainly be combining steps together. So the first observation is that it's a derivative of a sum, So we can break this up as a sum of derivatives. That is, we can take the derivative of the first plus the derivative of the second. With the first term, we can apply the power rule to it directly. You'd say it's x raised to the number 4, so we bring that power out front, and our new power is 1 less than 4. Before we apply the power rule in the second derivative, we note that 5 is a constant, and we can pull that in front of the derivative. So 5 derivatives of x squared. So we have 4x cubed plus 5. The derivative of x squared, we use the power rule. The 2 comes down front. The new power of x is 1 less than it previously was. So the final form of the derivative will be 4x cubed plus 10x. And let me once again mention that after you go through a few of these examples, for something like x to the 4th plus 5x squared, you will hopefully be able to very quickly, with very little work, write down the derivative.